Last part of chapter 12, we're going to be looking at more identities. And again, in order to get good with these, you just got to do a lot of practice. There's no real quick shortcut to take. So here are the sum and difference identities, as well as the double angle identities. We want to use those identities to simplify this expression. And what we can notice is that this is of the form of the sum angle identity for cosine. Cosine, cosine minus sine, sine. That's cosine of something plus something. Those somethings are 3 theta and theta. So that original expression is just another way of writing cosine 4 theta. We can also use these sum and difference identities and double angle identities to find exact values for trig functions that aren't one of those nice unit circle type angle measures. 75 is not one of these special triangles that we have from geometry, but we can think of 75 as being 30 plus 45. And those are two angles that we know sines and cosine values for. So now I'm going to expand this using my sum identity for sine. Sine 30, sine, cosine 45 plus cosine 30, sine 45. And now those are all things that I know the exact values for. The sine of 30 is 1/2. Cosine of 45 is root 2 over 2. Cosine of 30 is root 3 over 2. And the sine of 45 is square root 2 over 2. Simplifying this, we get the square root of 2 plus the square root of 6 over 4. That is the exact value for sine of 75. Now we're going to sort of work backwards. I know that some angle is acute, and I know that the cosine of an angle twice as big is equal to 3/4. What is the original angle? Well, we can use our double angle identities for cosine to find both sine of alpha and cosine of alpha. We know that cosine 2 alpha by the identities is equal to 2 cosine squared alpha minus 1. Now we don't have that double angle. We're only looking at just the cosine of alpha. We can solve for cosine alpha. Add 1 to both sides. Divide by 2. And square root. And normally we'd go plus and minus at this next step, but because alpha is acute, meaning a first quadrant angle, both sine and cosine have to be positive. And with radicals, you really should simplify them. You should pull out and simplify the square root of 8. If you want to rationalize, you can. I've noticed that IB isn't too picky with that, but we could write this as the square root of 14 over 4. Now we can do the same sort of equation solving using 1 minus 2 sine. And solving this equation, going through the same steps, we end up with 1 over the square root of 8 equal to the sine of alpha. And we can simplify that to 1 over 2 root 2 or square root of 2 over 4. This last problem asks us to simplify. Again, we don't really know what we're supposed to be getting. We're just trying to make this as simple as we can. And first thing I notice right off the bat is that both of these terms have a 2 in them. So I'm going to factor that out. The 2 that's with the b here needs to stay there. That's not a coefficient of 2, but a double angle. And that should be a 1, not a 2. If you're wondering why my writing is so strange right now, my pen battery died, and I'm having to use a mouse to do all of my writing at this point. Now, this thing in parentheses, that looks an awful lot like a double angle identity for cosine. Slight difference being, instead of just having an angle here, I have a double angle. So it's the double of a double angle. In other words, I can write this as 2 times the cosine of 4b. And there is a simplified way to write the original expression. And again, the only way to get good with these things is to work with them. You'll get more familiar with them. You'll start to see how they fit together. And the last couple sections in Chapter 12 do a lot more with these identities. So you just need to practice. There's no easy way around that.